In case you missed the last part of the series, we got the layout of the building complete, including setting up a string line at grade, and also dug the holes for the concrete footings, which will make up part of the foundation of this house. The next step in the process was getting the forms created for the footings, as well as adding all of the rebar that was specified in the building plans. Eric and Jamie, the Perkins Builder Brothers, were on hand to help with this process, and we started by getting our 10-foot lengths of rebar cut into 2-foot sections using an angle grinder. To keep the rebar pieces securely in place while the concrete was being poured, we needed to tie them together with pieces of wire. And we used pre-cut wire with loops at each end and used this wire twister tool to assist in tightening the wire. After adding the wire, we could drop the rebar into the hole for the footing, setting the rebar up on these plastic rebar chairs, which helped us center the rebar in the base of the footing. Once the rebar grids had been added to the footings, we could work on getting the sonotube set in place, 1 foot above the bottom of the footing, but first we needed to do a little bit of brainstorming.
What's that?
Yeah! Got a little wiggle room. We'll slice it off at the final height after it's installed and braced and not going to get moved. So it's going to be 1 foot off the ground, hopefully. Just got to figure out how.
Before setting the sonotubes, we needed to go ahead and add our J-bar, which will tie the base of the footing to the sonotube formed pier. And this particular J-bar, which Eric and Jamie picked up at the local concrete plant, had a little rebar leg welded onto the end, and we could drive that leg into the ground to help keep the J-bar in place during the concrete pour. And after driving in the J-bar, we used another wire tie to connect it to the rest of the rebar. To set the sonotubes, we would first measure the rough length of sonotube we needed, and we made sure to leave some extra length so that they could run above the string line so that I could cut them to final height later. Next, we cut the sonotube to length with a circular saw, and these are just cardboard so they cut really easily. Next, we marked the center of where the sonotube needed to be placed on our string line, and then set our J-bar at that location. We could then mark on the side of the sonotube where it needed to meet up with the 1x4 bracing, and then pre-drive some screws from inside the sonotube to attach it to the 1x4s. And we ended up switching our process a little bit later on, driving longer screws from the outside through the bracing into the sonotubes, because it was super awkward to try to drive the screws on the inside of the sonotube with the J-bar in the way. We then just repeated this process of setting the rough positioning of the sonotubes on the rest of the footings. Unfortunately, the inspector also came out right about then, as I had called in the footing inspection that morning, and he failed us because we didn't have all of the footing forms completely set up. He also mentioned the fact that the building plan specifically called out an 8-inch spacing on the rebar grid, which we hadn't done, so we had to go back and adjust our spacing there as well. Anyway, back to setting up the forms. Next, we drove in a stake at each end of the 1x4 bracing so that we could more firmly attach the supports to the ground. We screwed the bracing to the stakes, making any adjustments to ensure the sonotubes were level and centered in the holes while doing this, and we could also add extra screws through the bracing into the sonotube to further secure everything if it felt like it needed it. We repeated this process on the rest of the footings, and you can see we also added some diagonal bracing on some of the taller footings at the right end of the building. We called it a day at that point, and I got up bright and early the next morning before the sun rose to cut the sonotubes to length. And I first got my line laser set up at grade to the height of the batter boards and string line, and then I could get the sonotubes cutting along that laser line. And getting to work before the sun was up really helped me see my line clearly, and I cut the sonotubes using a cutoff wheel on the angle grinder. And as you can see, as I cut through the face of the sonotube facing the laser could actually shine through on the inside of the back face of the sonotube, which made it really simple to just kind of work my way around the sonotube cutting to my line. I repeated this process on the rest of the sonotubes, and after I had them all cut to height, I double checked my work with a string line which ran across the top edge of the sonotubes pretty much perfectly. Also, I called in a second footing inspection at this point, and thankfully I passed as the concrete arrived later that afternoon. So I had never done this kind of concrete work before, so the process was a little bit confusing to me, but basically I was working with 2 separate businesses. The concrete plant, who I ordered the concrete through, supplied the concrete in their mixer truck. And then the concrete pump truck operator then ran this concrete through their pump to get the concrete into my backyard. I ordered just over 4 yards of 3,000 psi concrete, which was specified on the plans, and I requested a 3-inch slump, which the pump truck operator recommended. And I had never heard this slump terminology before, but evidently it's a measurement of the consistency of the concrete, with a higher slump number indicating thinner, less viscous concrete. So for these footings, the pump truck operator recommended a 3-inch slump so that the concrete would be thick enough to stay in the sonotubes and not just flow out the bottom, displacing the other concrete in the footing base. Back on site, the pump truck operator could operate the pump with a remote, which allowed him to control the feed rate of the concrete, and he could then start filling the footings. And he first filled the base of the footing, adding concrete until it met up with the bottom edge of the sonotube, and then he partially filled the sonotube. He then moved on to the next footing, again filling the base, then part of the sonotube. Next, I added a few more pieces of rebar in the sonotube, both to further reinforce the sonotube area, but also to help get rid of any large air pockets in the sonotube. After I added the rebar, the pump truck operator would come back to top up the sonotube, making sure it was slightly overflowing so I could screed it level later. And we repeated this process on the rest of the footings, which only took about 30 minutes. Once the footings were filled, the pump truck guys then needed to pump the remaining concrete out of their lines. Finally, after getting most of the concrete out, the pump truck operator ran a sponge through the line to help clean out any remaining bits of concrete, and this sponge comes out the other end like a rocket. With that, the pump truck guys headed out, and I could get to work screeding the top of the footings to ensure they were flat and level. And I just used a straight piece of wood to do this and made sure to saw the board back and forth to remove any excess concrete. And having that J-bar sticking up definitely made this a little bit more difficult, and if I did this again, I'd just go ahead and cut those pieces to length before pouring the concrete. And after all the footings were screeded, I let them cure overnight. The next morning, the concrete was cured enough to remove the forms, and then I could get to work filling in the dirt to cover up the base of the footings, which was made much easier since I still had the excavator rented. I also moved that giant concrete boulder out of the way, and I still need to figure out what exactly I'm going to do with that thing. I filled in around all the footings, and then since I still had the excavator for the rest of the day, I decided to go ahead and dig the trenches for my power and water lines, as well as my sewer line. So we're tapping into the existing water line that supplies our main house, and connecting this guest house to that water line. So first I needed to dig around in the rough area I knew our water line ran to figure out where to start my trench. And let me tell you, this bit of hand digging definitely made me appreciate the excavator even more, and after first finding our sewer line and gutter drainage, I finally found our water line so I could start digging the trench with the excavator. So building code in this area dictates that the water line has to be dug to a depth of 24 inches, the power lines need to be dug to a depth of 18 inches, and water and power lines have to be at least 12 inches apart. Because of this, I dug my trench to a depth of at least 24 inches with a width of roughly 18 inches, which was the width of the bucket, and this gave me plenty of space for both lines. I ended the trench roughly under where the bathroom and kitchen would be, since I knew most of the water supply would need to be there, and then I could work on the sewer line. Again, we'd be tapping into our existing sewer line, which runs kind of diagonally across our backyard. I dug the trench for the sewer starting in that area and actually used the excavator to help pull down a small tree that was directly in the path the sewer line would need to take. Once again, I dug the sewer trench to the bathroom area, basically almost connecting the two trenches, and then I had to return the excavator, unfortunately. And I definitely say I got my money's worth out of this rental and burned through an entire tank of diesel, with the machine basically running on fumes as I loaded it back onto the trailer. Anyway, after letting the concrete continue curing over the weekend, Eric and I got back to work on the foundation the following week, starting with removing the sonotubes from the piers. Next, we cut off the protruding J-bar, which proved to be a little bit tricky because of all the concrete surrounding it, but we eventually got them removed with an angle grinder and a cutoff wheel. Next, we needed to get the 6x6 post base brackets attached to the piers, and these will connect the concrete piers to the wooden girders. And we could have done this a few ways, and there are post base brackets which can be cast directly into the concrete, but since I knew I'd be finishing the concrete on the piers by myself, I opted to instead just use these massive 5/8 inch wedge anchor bolts to attach the brackets, since I could drill the holes for them later. To install the brackets, we first marked the hole location for the wedge anchor bolts, which was basically dead center on the piers, and then we could drill the hole with this massive 5/8 of an inch SDS max bit. And before drilling, I marked my hole depth on the bit using some painter's tape. And I was lucky enough to have access to this beast of an SDS drill to drill these holes, and this thing was just comically large.
Yeah, here you go.
Say hello to my little
Let's do a little
friend.
comparison there.
Yeah.
It's a little bigger.
Just
Oh, that was easy.
As you can see, this drill made insanely quick work of drilling these holes, and after drilling the holes to depth, we would then run the drill in and out a few times to remove any compacted dust from the holes. Next, we could pound in the wedge anchor bolts and then snug down the nut to secure the bracket. Unfortunately, the socket size for this nut was one size larger than the sockets I had on hand, so I had to use this tiny adjustable wrench to do this, but it was plenty tight to hold things in place. To set the brackets so they were all in line, we measured off of our string line and set them all to the same distance off of that line. And this measurement didn't need to necessarily be a specific number, since the floor framing overhangs the beams at both ends. We just needed the measurement to be consistent across the brackets so that they were all in line. We repeated this process for the rest of the piers, setting the brackets in line, and then we could get to work building the girders or beams, but first we needed to go buy a whole bunch of lumber.
How much weight did you say this would hold?
we'll find out. Still pretty good.
Yeah?
I think I've got like...
Yeah, you've got like an inch of suspension left.
These girders are made from 3 layers of pressure-treated 2x12s, and since our footings were roughly 12 feet apart, we could use 12-foot-long boards for the center sections. We wanted the layers to overlap slightly so that they were tied together well, but we also wanted both ends of each board to be supported on the post-base bracket. To accomplish this, we only cut a few inches off of each board, staggering this measurement by about 4 inches on each opposing layer. And this allowed each board to still land on the bracket at both ends, but allowed the boards to overlap enough to create a nice strong beam. After cutting the first 2 boards to length, we started the process of assembling the beam by nailing these first 2 boards together. Before nailing, we made sure the boards were vertical using a level, so our girder didn't end up with a slant to it, and we nailed the boards together using 3-inch galvanized ring shank nails. So this pressure-treated lumber definitely wasn't perfectly straight, and Eric had another great trick for getting these boards flush with each other. He would first add a temporary nail or screw as a point of leverage, and then pry on that with his hammer, flushing up the top edge of both boards. We could then nail the boards together, which set them in place, and then once they were nailed together, the temporary nail or screw could be removed and we could move on down the board. You can also do this another way by adding a spacer between the 2 boards, and a speed square is perfect for this, and then drive a screw in at an angle. And the spacer here helps to give the screw more room to pull the high board into place. Anyway, after tacking the boards together, we would go back and nail them off, adding 3 nails in a row vertically, roughly every 16 inches. Also, this was Eric's first time using a cordless framing nailer, and needless to say, he was pretty impressed.
Dude, that's not bad.
After nailing off one side, we could add the 3rd layer and nail off the opposite side using the same nailing pattern, and then we had one section of the girder built. To attach the girder to the post base bracket, we use these 1.5-inch long connector screws, which are specified by the manufacturer. And these are specialty screws meant for this application, not just your regular deck screws. And I'm just mentioning this as you will likely fail your inspection if you use a different type of screw here. We could then continue on building the rest of the girders, working out from the center of the building until we got to the end sections of the girders. And we needed to switch to 16-foot 2x12s here, since we had a longer overhang at each end of the building. And we let the boards run wild at the ends and cut them to length after assembling the beams. Before cutting the beams to length, we needed to attach the inside face of the post base bracket to the beam, but since we used a 6x6 bracket here, which had an actual inside dimension of 5.5 inches, we needed to add a little filler piece here. Luckily, a 5/4 pressure-treated deck board was pretty much a perfect fit, actually a little bit on the snug side since this wet treated material was a little bit over thickness. We attached the spacer to the beams using more nails, and then attached the bracket to the beams using longer 2.5-inch connector screws to make up for the additional inch of material we were screwing through here. Finally, we could get the girders cut to length, and we started by marking out some layout lines using a 12-inch speed square, which we could reference off of our string lines. And after thinking about it, we decided the best tool to cut these beams would be my electric chainsaw, since it could cut through the entire beam in one pass. And I was afraid it might be a little tough to get a clean square cut here, but it was actually pretty simple to cut to my line if I just took my time.
Dude, that was easy.
Dang.
That is a shockingly clean cut too.
Yeah.
Whew, not bad at all.
And Eric, of course, had to try his hand at this and was equally impressed.
I mean,
What the heck, dude? I don't ever gonna use a skill saw again.
yeah. I don't think there's any better way to do that.
We could check our accuracy, and we were pretty darn happy with the results.
Oh my gosh.
Wow.
Look at us, dude. Look at that.
That's the best I've ever done. That's really good.
That's pretty good.
We repeated the same process on the other beam, and then we could officially call the foundation finished.
Whew, it's getting cold out here. All right, hopefully you guys enjoyed part number 3 of the Not So Tiny Tiny House build series. Stick around for part number 4, where I'll be covering all of the floor framing and getting the floor sheathed. Go ahead and get subscribed and ring that notification bell if you don't want to miss that video. And last, I want to say a huge shout out to all of my supporters on Patreon and my YouTube members. If you guys want to check out both of those programs, I'll have a link to those somewhere on the screen as well. All right, thanks again for watching, y'all, and until next time, happy building.